Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is James Montemagno. Hey, James.
Hey, Robert. How's it going?
Good. James is from Xamarin, and this is now your 7th time on the show.
Yes,
which
7th
I haven't
time.
done the actual math, but it's got to put you way in the lead as the most, as the guest who's been here the most.
Well, when you talk about cross-platform mobile development, you can hit so many different areas. I think we started with just introduction, then Azure support, offline, and now there's just a whole world. Now we're even talking about games, which is great.
Which is cool. So we are in the second half of the second marathon. This is episode 3 of the 4. We did Xamarin Forms. We did the iOS Designer inside Visual Studio. Today we're going to switch gears a little bit and talk about games.
Yeah, we're going to talk about CocosSharp, which is a brand new library and game engine that we're introducing. We introduced already to build 2D games all in C# and .NET that run across any platform, really.
Cool. So you'll give us a little bit of a lay of the land. What is Cocos? How does it maybe high level kind of compare and contrast it to some of the other engines? Kind of get a sense of what you can do, because there are a number of game engines.
Yeah. And a lot of different game engines you're writing in different languages that are out there. It could be C++, could be Objective-C, it could be a whole lot of different things out there. And obviously C# as well. But we try to focus on a few different key factors when building CocosSharp. And we'll talk about the history of Cocos 2D, because a few people might have heard of Cocos 2D. It's a very large game engine. It's open source. And that's kind of where CocosSharp came from.
Okay.
So let's talk about it. So there's actually a few ways to build games with Xamarin. The first one that a lot of people may have heard of is MonoGame. It's actually an open source implementation of XNA, which I'm sure you've heard of, to build games on Mac desktop, on Linux, on iOS, on Android, all in C#. So these are powerful 2D and 3D games. It's a very big game engine as well. So games like Towerfall were built with it, which is an awesome game that you can get on Steam. Good friends with those guys. Bastion, for instance, was also made with it. Transistor, a lot of different awesome games. You can go to monogame, I think .org, and find all the awesome things. But it's really, it's a larger engine. Lots of things, it's a big barrier of entry, but really powerful. Okay, so you got to be you need to be a serious gamer, basically building games for a living, essentially, to do that, right? That's the kind of thing that you'd play around with on the weekend? You could definitely play around with it. Yeah, okay. I mean, if you liked XNA, too, especially if you're an XNA developer, imagining taking your XNA game and then porting it to other systems as well. So if you're familiar with XNA, want to get up and running, MonoGame is a good way to transition to cross-platform. Okay. But it's a little bit bigger. Now, Mono for Unreal is a brand new library that we introduced, so I'm sure you're familiar with Unreal. So Mono for Unreal works on PC and on a Mac, and it's an open source project. You can learn more about it. So it's obviously Unreal Engine, and that's pretty cool. It's not on mobile, though. Okay. There's a few engines built into core iOS that are extremely popular that kind of lead into the CocosSharp for 2D and 3D gaming. So SpriteKit is just built into iOS. So when we talked about MonoGame, like that's very much cross-platform. SpriteKit is an iOS-only 2D powerful game engine. Then so that requires Objective-C? Objective-C or C# with Xamarin. Oh, okay. So, either way you're building with iOS. And then also, like really, when you look at iOS, there's like lots of things built into the core framework, such as SpriteKit, which is just another library built in for building sprite-based games. And then there's SceneKit. So these two kits here are actually really intense game and rendering engines built right into iOS. So the problem with these, obviously, is that it's only iOS. It's only, right. It's iOS only. Okay. So that's where kind of CocosSharp comes from. So we kind of see different images along the way. And CocosSharp really, I think Miguel kind of says it the best before we talk about the history, is that Miguel said that CocosSharp, it blends everything that people love about Cocos 2D programming model with C# and the .NET framework. And then, of course, that API that you're developing against is always C# and .NET idioms. Okay, so the Cocos 2D program framework came first? Yeah, so Cocos 2D is an open source project, and you can find it at cocos2d.org. And what that is, it originally was for just OS X and iPhone and desktop, really. And it was all in Objective-C. There's a lot of flavors that have been spun off since then. So there's Cocos 2D X, which is actually cross-platform in C++, and that was brought over to multiple platforms. Then there was Coco's 2D Sprite Builder, which was more for Objective-C based, but for iOS and for Mac and for Android a little bit as well. Again, Objective-C.
Okay.
And then there was Coco's 2D XNA, which was kind of built on top of MonoGame and took the Coco's 2D programming model and brought it on top of MonoGame with C#.
Okay.
So when we say CocosSharp blends everything that developers maybe know about Cocos 2D with C# and .NET, the problem that kind of occurred is that all these Cocos 2D engines just kind of took the Objective-C library with delegates and all these weird callbacks and whatnot, but didn't apply all those C# and .NET idioms.
Right.
So what we did is we,
so if you already know Objective-C, that's great. But if you're a C# developer, it kind of doesn't help you much.
Yeah, so when you go to like read through the APIs,
Yeah.
you're like, oh, this doesn't make any sense. So when you're developing just normal iOS and Android apps with Xamarin and C#, you have a click handler,
Right.
plus equals, and then all of those normal idioms that we know and love, the naming all makes sense.
Okay.
What we did is we took a fork and completely, it's open source as well, so CocosSharp is open source against MIT license. And we added all these C#, .NET idioms, and we cleaned up a lot of the APIs for .NET developers that are coming in that will understand it. And we'll see that as we walk through some code. It's very simple with simple callbacks and events in there as well. And we cleaned up one thing, which is you kind of have these scenes. So the nice thing about CocosSharp is it's node-based. So everything's nodes with a scene and with layers and with nodes, which are actual sprites or layers or fonts that you're putting down. So we cleaned up some other things to make it more mobile friendly, such as the director that's directing scenes. Like I want to go to this level or that level or the game over screen. We really made it. It used to be a singleton, and now it's no longer a singleton. So that opens up a whole series of things that you can do, especially when you're on desktop. You might have multiple screens open as well, multiple HUDs, things like that. So that's CocosSharp.
All right.
Yeah. Now, there's, of course, a lot of other game engines out there. I mean, you can roll your own game engine. There's Unity. There's a lot of other things with builders and, level editors as well.
So just then, quick overview, elevator pitch. When would I use Cocos 2D? When would I think about using Unity?
So Cocos 2D and CocosSharp is if you want to get in and build out a great cross-platform 2D game.
Okay.
It's really focused on 2D. There is some 3D aspects to it as well, but it may not be the most complex game in the entire world. You can make some fun games really short, get them up and running, and then automatically, just inside of Visual Studio with shared projects or file linking or portable class libraries, just bring all that code over inside of there. You're not really worrying about building this huge 3D scene out and leveling. It's just very to the point of what I want to do.
Okay.
And it's
So
also
it's a good choice for somebody that just wants to start playing around with games.
Oh, absolutely.
Right?
Yeah.
Like I'm not gonna quit my day job and build games for a living, but it might be kind of fun to bang out a couple games just for the heck of it.
Oh, totally. And there are actually people that have really successful Cocos 2D games that's actually what they do. So on mobile, sometimes obviously 3D isn't exactly what you need. A great 2D game can be extremely successful as well. So it's just kind of a fun, see if you're a C# developer, want to get into games a little bit, play around. I was at a game jam in Arizona last year, and I was able to make like a really awesome game. I called it Nibbles. It was like this game where like these balls got bigger, and you had to connect them to pop them, for instance, and you had 60 seconds. And I built that game in under 20 hours across 3 platforms, which is pretty cool.
Yeah.
And I've made games. I used to work on Xbox 360 games back when I was, so I went to school for originally, actually. So it was really different working on this huge 3D, Xbox 360 game to like focus on mobile, because it's a different idea too. A lot of larger 3D game engines are based around the controller input. When we're actually on our phones and we're worried about touch input.
Right.
So CocosSharp has a touch-based, event-based first API.
Okay.
Yeah.
Cool.
So before we get into code, we're going to build out a simple game, but I wanted to kind of break down the API and the structure of a game.
All right.
So it's all based on the point of an application. So an application is your iOS application, your Android application, Windows Phone, Windows Store, doesn't matter. And inside that's an application delegate.
Desktop as well?
Desktop as well. Yeah, it could be, and we'll see that there's like multiple.
So it doesn't have to be a mobile game.
Doesn't have to be, no. It could be just desktop as well. It could run on Mac as well. It doesn't matter. You can run this game anywhere.
Okay,
yeah.
cool.
So the application handles application things,
Yes.
right? So starting the game, pausing the game, and you can put in like your application lifecycle events in there as well. And it also handles building the game engine on each, so like the different device drivers that need to be loaded, because obviously that's very different from iOS to Android to Windows, but we handle that for you.
Right.
So, and then there's this thing called director, and I mentioned this a little bit. And the director is kind of like, it's almost like the puppet master.
Were those the fancy transitions you were telling me about earlier?
Those are the fancy fade-in transitions that I did, yeah.
Awesome.
I said I put a lot of work
I'll
into...
stop waiting for them with bated breath.
I was like, I told Robert, I said, I put in tons of fancy PowerPoint animations here. Actually, the hardest part is just like getting arrows to look correct. You know, PowerPoint master. You'd think after a year and a half I'd be amazing and whizzing around all over the place. So the director is like a puppet master, right? It's kind of directing all of the scenes of your application. So it points and it's directing where to go. So if a game ends, you tell the director to move to the next scene.
Okay.
So that's where the scene comes in. So we're kind of now going down the chart. And the scene has layers. So each scene, you can think of it as a level of your game, or the start of your game, the credits of your game. Those are scenes.
Got it.
And each scene has layers. So there's multiple layers which contain nodes. So for instance, I might have a layer that has labels, a layer that has sprites or menus on top of it. So a scene can have multiple layers, so you can layer things on top of each other. You could add depth to them, for instance. And then obviously a layer has nodes. In this instance, my sprite layer has some sprites.
Okay.
But everything is node-based. So if I have a node, I can apply actions to a specific node, to all the layer, to the specific sprite. That's why it's node-based, if that makes sense.
Yep.
But this is what our game looks like in general. And there's a lot more layers as well, like sounds and things like
Right.
that, and particle effects.
Yeah.
So if you've never really looked at the a game engine before, you usually have like a game rendering loop as well. So you're rendering out those layers over and over again. That's kind of what's happening here.
Okay.
So cool.
Cool.
There we go. And there's a lot more too. So things that we can also talk into as well, and we'll demo a little bit. But there's cross-platform accelerometer support, audio support, primitives. So if you just want to draw lines around and vector-based, basically, you can do that, which scales really nice. We have particle effects, so you can have explosions. We'll see some of that as well today. And there's some built in. There's also tools. There's a lot of cross-platform particle generators that people are used to, and they all export to a familiar API that'll just come right into the game.
Okay.
We also have parallax, which is kind of cool. As we see like the little monkey move, the clouds move up and down. This is one of our sample games that we ship. It's a little parallax, this is actually relatively hard. You would say, like, have this monkey. So if I go back and forth, you'd normally have to program this and say, move the clouds up and down based on the scale. But there's just a parallax node that automatically does it for you. It's like one line of code to automatically scale things, which is cool. And we have effects such as like wobbly and all this craziness going on. So there's a lot built into it, as well as physics. So there is a complex physics engine here as well that's going on as this goes up and down this box. You can see like the physics engine going in. And we have an amazing samples library that breaks down every little thing that you can do.
Cool.
Cool. So there's a lot built in. So it's not just simple, I guess.
Yep.
We're going to show a simple example, but we'll really go in depth. So
let's build a game.
Let's build a game. So I told you the game that we were going to build is something very simple. It's going to be this little ball that bounces down, and we can knock it up and kind of keep it up as long as we can.
Okay.
That'll be the idea. I also wanted to mention that you can actively contribute and open issues and see the entire progress of everything, how this was built on GitHub, github.com/mono/CocosSharp.
Okay.
You can see everything that's in here from our Wikipedia page. We have samples, all of everything in here. Our Wikipedia page is really fantastic for going through. You get the API improvements, key differences, NuGet packages. Everything's distributed on NuGet, which is really cool. And also how to get the project templates, which is where we're going to start this game. So the project templates, I've gone and I've installed the Visual Studio templates here. So that's the very first thing. So when you install Xamarin, you're not just going to see these magically. You're going to have to install these. They just come from the gallery as well. So that's kind of the preface of where we're about to go. So when we do that and we say new project, we'll see a new entry called CocosSharp. And inside of here, we'll see Android, iOS, and Windows.
Okay.
And notice when you go to Windows, There's Windows Phone, Store, Windows Store XAML, and a Windows GL or a Windows DirectX. So you can kind of depend and debate what you want to go with, but all your code will be shared. So it's kind of the core game engine is what you're picking.
Okay.
So I'm going to start here on an Android empty game, and we'll call this Bouncy. Let's see, Android, and we'll clean up the solution name there and create it. So what this is going to do, it's going to set up our core game and download all our NuGets automatically for us, which is very convenient. It'll actually set up like a little default game scene that we can actually run and actually see what it looks like here. So we can see down at the very bottom, it's actually installing our Cocos 2D stuff, and we're good to go. So let's take a look here and see what we have. So automatically by default, we're going to get a program, which is the base of our application. Now, this is going to control if you want landscape or portrait mode, and this is going to set up our application. So this is our main activity of our application, and we're kind of good to go. So I'm going to change one thing. This game is going to be all portrait, so we're going to change it to portrait. So we'll see screen orientation. We're going to change that to portrait, just so it kind of stays correct. And you can obviously adjust for that as well. One other thing I'm going to do is we're going to make a few modifications here to our compile. So if you've seen some of our other videos, you've seen like what kind of do we want to support. So what I'm going to do is come into properties, and I'm going to say that I would like to run this on a few older devices, but not all older devices.
Right.
Great. Okay. So very simple, just a little bit of modification. And then we'll see this app delegate. So our app delegate here is what's going to control our life cycle. So it's going to set a few things for us. It's going to set a content directory. It's going to set up our default window for us, and it's actually going to start our game. Down here, we are creating a new scene, and we're adding a layer to it, and we're going to run the game with the scene.
An intro layer is a class that exists, okay.
Yep, it's a class that exists, and that's where we're going to write all of our game logic. So this is just going to be one layer of an application. You'd imagine you have multiple layers with multiple scenes, for instance, or a scene might have multiple layers that you're transitioning through. Okay. And then you can see here we get some application events like did enter background, will enter foreground, things like that, which are pretty convenient. So since this is landscape, we're going to go ahead and change the desired width from here. So the width we want 768, and we'll change this to 1024. Now CocosSharp will automatically fit the screen resolution as best as it can. So we can see here that it's set design resolution, and these are just desired widths. So it's going to do its best to fit it on the screen size as best as it can based on the aspect ratio. But you can always modify that, and you could always have platform-specific code in there as well. Okay. So let's go into our intro layer and see what that looks like. So this is where all of our sprites are going to live. We're going to start building out our nodes. So by default here, we have a layer of a color, and down here it's actually color blue, which is kind of the background color, and it adds a label. So this is a CC label. So everything is prefaced with CC, which is Cocos.
Right.
There. So Cocos label. So if you're actually reading the CocosSharp or Cocos 2D documentation, it follows those idioms. So it's not quite 100% C# idiom, but we didn't want to lose the Cocos part of that because just naming conflicts. So let's take a look here, and we can actually go ahead and run this game. Let's go ahead and build it here. We can also take a look at the references. You see, it actually added tons of different references here. We have CocosSharp and MonoGame and OpenTK and a bunch of other stuff in there as well. So that handled it all for us as well. So if we run this game that we have so far before we start adding objects on here, we'll actually just see, hopefully, a blue background with a label that says Hello CocosSharp. So go ahead and build it up and deploy it right onto our Android device here. There we go. So maybe not the prettiest thing in the world. So let's go ahead and change this up a little bit.
So it is at the moment absolutely the world's worst game ever.
Worst game ever.
It doesn't do anything.
Doesn't do anything.
But it works.
But it totally works.
Yeah.
And if you actually ran this on iOS and built in that project, it would totally work as well.
Yes.
So that's cool. But let's go ahead and do some stuff. So let's add in some CC. So we get CC, and then everything for Cocos comes up. So let's add some sprites. And we're going to add a paddle sprite and a ball sprite. There we go. And then we'll go ahead and new those up here. So we'll say paddle sprite equals new sprite. And it is going to want a file name. So we can actually pass in a default file name of what this file will be. So I actually have them here already. So I have a little folder, and I have a ball and a paddle. And we can, if I open that up, we can see what it looks like. Okay. It's a ball. So let's go ahead and copy those in. And we're going to put those inside of here. So all of our assets and everything live inside of our assets content folder. We'll drag those in. And now we can say this will be our paddle. And then we will say add child. And then we will go ahead and say paddle sprite. Perfect.
So does that paddle literally refer to paddle.png in the content folder?
Yeah.
Or is this more of a virtual, it's a sprite called paddle, but it's not associated with literally the paddle?
So you can do sprite sheets as well, where you can actually go ahead and pull items out of a sprite sheet. What this is doing is it's looking for the first file that has paddle, dot. Okay. This allows you to actually name it a little bit different. When we go to Windows Phone, we'll see why as well. So there's paddle in there. And the reason that this works and it knows it's in content is because up here I said my content root directory is content. Okay. So that's what it's looking for under my assets. And then you could put sounds, and you can have high definition files as well in different fonts. So let's go ahead and do ball sprite equals new CC sprite. Ball, add child, and we'll go ahead and say ball sprite. Perfect. So we've added 2 new items to the scene, but we haven't given them any context yet. So we can actually see, let's make this black as well. So we'll set that to a black background. Perfect. All right. Now what we want to do is we want to go ahead and do 2 things. We want to go ahead and first just put down the ball, and the paddle on the screen, give it some default X and Y position. Then we're going to add some logic to actually have the ball fall. Then we're going to do some interaction with the paddle as well. So after this constructor got called where we added those items to the scene, we're going to get an event called added to scene. Kind of makes sense. We're kind of like getting ready. And here we can see that the position of the label's been added to the center of the screen. And we can also go ahead and say paddle sprite dot position, and you can set the position X and the position Y. So let's go ahead and set the paddle sprite just equal to 100 and paddle sprite dot position Y equal to 100. We're just kind of hard coding them here, but these are just pixel based. Then we'll say the ball sprite dot position X. We'll set that equal to, let's just put it in the middle, 320, and ball sprite dot position Y equal to 640. So this is all kind of down on the bottom lower left is our origin. Okay. If that makes sense. So we're hoping that the ball and the paddle are paddle's on the bottom left and the ball is kind of in the middle of the screen. And let's go ahead and just move this here, this position. We'll say position equals say Y equals bounds. So this is our bounds, our visible world bounds. We can say minimum Y minus 30. That should work. We'll see if the label still shows up. So we kind of want to set it to a little bit lower on the screen. We'll see if that's correct logic off the top of my memory. So again, it's going to recompile up the application and then redeploy it here on the Android phone. Okay. So it looks like my label's gone, so we can try to find where that goes. But as we see, we have a paddle and we have a ball. Yep. It's totally happening. We almost have a game. Almost. Almost. All right. Let's let me just put the score back in the middle just to see where it's supposed to be. I have a full working example on my GitHub of exactly where it should be. Okay. So off the top of my memory, it should be there. But let's check this out. When I move, so now what we want to do is we want to move the paddle. So wherever I touch on the screen, if I tap here, I want to move the paddle there. So you're imagining I'm going to get a touch event, and then I want to move it somewhere. So we can do one of 2 things. And the first thing that we actually get in this template is the CC event listener touch all at once. So it's saying anywhere I touch on the screen, let me just get a touch event. So there's a few different touch events that we can get. We can say on touches ended, moved, began on here. So we can just say on began. So every time I touch down, we'll get a touch event. So sure enough, it's already set up for me. It's kind of nice. The default template kind of knows what we're going to do.
Right.
So let's go ahead and say, whenever I move, and I have a touch, I actually have a touch, let's move that paddle sprite. Now, we don't want to move the entire position. What we could do is we could say position equals our first touch here. We could index in on the first touch, and you could do multi-touch dot location. Now, this seems like a good idea, that I just move the position to wherever I touch on the screen. But if we run this again, we're going to see that this is probably not the desired effect that we want to do, because we'll find out. I'll just touch on the screen because it's kind of fun. So now you can see I'm kind of moving the paddle everywhere. That's not really what we want. What we really want is it to slide left and right, back and forth, right? So let's go ahead and change this logic. So we will say, we could come in and then say position X, and then touches, you know, sub-0 dot location dot X. Like, we could do that. But we could do something a little bit better. We could actually add a action onto this. So we're going to call this thing, you can run multiple actions on a sprite at the same time. And an action is multiple things. So there's action in here. If we actually just look at action. So there's a lot of different actions like easing and different states and tweening and all this stuff. What we actually want to do is do a move action, or move to. So what we can say is we can move to a position over a time, and it'll automatically interpolate that for us automatically. So we move that over point 1 to a new position. We can say new point and pass in an X and a Y. So we want the paddle dot Y dot position Y, and then, oh, sorry, that's the Y that we want. We're going to pass it the X first, and the X that we want is the touches sub-0 dot location dot X.
Okay.
There we go. So we're going to move it to this new position on the X and the Y, and it'll go ahead and figure that all out for us automatically. And you can run multiple actions. So these will actually chain things together. So if you actually run multiple actions, it'll go ahead and manage that for you automatically. That's new in this API. So you don't have to worry about managing the action, like, oh, make sure that this action's finished before starting a new action. We handle that for you automatically. So now we can see that it automatically is a nice little smooth transition whenever I tap on it. All right? So not bad. Cool.
That does not let you drag it yourself, though, right?
It doesn't. So it's every time we touch down on it here. Now we could do a little bit more logic in here, such as on moved. We could say every time we move it, then we actually get it. So ideally what we want to do is every time I do moved, and also when I begin touch. Does that make sense? So when I touch down, move it, and also when I move it, move it as well. And we'll give it the same action here. That's a good point. Because obviously you want to actually just be able to drag this around, right? Is the idea. But you don't want it to be jerky.
But is that going to be when you touch it or when you touch?
Ah, good question. So this, what we're applying it to here is we're touching it on the entire screen.
Okay.
Now what you could do at this point, so we only had 45 minutes or so to do this. What you could do is you could actually do some bounding box logic to say, did the user actually press and actually touch the paddle?
Right.
And if they didn't, then don't allow them to do it. But remember, you're on a mobile device.
Yep.
So the paddle's only so big.
Yes.
So you might just want to allow them to touch it here. So now as we can see, as we drag across, we're actually getting a full update in real time as well, which is kind of cool. Right? Boom. Answer, problem solved. All right, so to speed up a little bit of time, what we want to do now is we want to drop the ball down to the bottom. I have a code snippet, a little game logic here. So, but I'm going to walk through it, just because I don't want to write an entire game loop logic here from scratch. But this here is called run game logic, and this is kind of just a default method that'll get called every single frame that I need to update, and you can have it update on intervals. Because not only does this layer handle the sprites, but it also has its own game loop, so it can just handle logic as well. So what we want to do is we want to have some default gravity here that says in a velocity x and y. So this ball is going to move x and y down. It's going to have certain gravity that pulls it down. So what we'll do is every single frame that it needs to update, we're going to pull in a little bit of logic to actually move the ball down or up based on its velocity, because you might be launching it up. Once it hits the paddle, we want to launch it up, right? So the velocity is what's controlling that. And then there's a little bit of game logic here to actually handle it, a little linear approximation. And then to actually see if the ball has touched the paddle, we're going to actually use this method called bounding box transform to parent, which is pretty cool. So it puts a bounding box around that sprite, and with this one method, it'll tell us if it's overlapped. Okay. So one method to put a bounding box around it, which is a pretty good approximation. It's not like a circle around it, but for all intents and purposes, you can build multiple bounding boxes as well. And of course, we want to make sure here if the ball is moving down. So is our velocity on the y less than 0? Because we don't want to actually do any of the bounding box stuff and bounce it back up if it's not moving down.
Okay.
Right? Because this is the one issue that a lot of people will run into right away, is that they say, okay, it hits the paddle, and then I want to launch it back up. But on the next frame, they're probably still touching, right? Because you've only switched the velocity. You haven't actually moved it up off the paddle. So you always want to make sure that not only is it colliding with the paddle, but also, are you moving down? Do you actually want to perform another action to reverse the velocity? So when that's the case, where I'm overlapping and I'm moving down, simply flip the bit here.
Okay.
Flip the velocity. I'm resetting some defaults here, and I'm creating a random velocity. So that way, every single time on the X, I can push it in a different direction, left or right as well. And at that point, what we're going to do is check to see if the ball, we want to make sure that it just doesn't fly off the left or right side of the screen. Okay?
Right.
So.
Okay, so I was just about to ask that. You have to check that yourself. It's not built in that it knows when it's hit the edge of the screen.
Yeah, correct. Okay. I mean, because the whole idea is, you might be scrolling an entire layer up, right? You might be scrolling, you might be moving up a crazy X and Y axes. It's almost like a world landscape. It's like a space landscape with just infinite area to move on.
Okay.
You have your game bounds, which is what we're seeing here. We have this visible world bounds, and that will automatically tell you your max X and your max Y. So here we're just going to check our min and max X that are here. And then we're going to see if we should reflect backwards. So we actually are detecting if we need to bounce off the paddle, or now at this point, if we need to switch our X velocity, left or right. So it'll just check to make sure that if our ball left or ball right, to make sure they're on the screen. And that's it. So that's a little bit of game logic in there. So we want to do a few things up here. So now that we're back into our added to scene, we can go ahead and say run.
Game logic?
Oh, sorry, schedule. Schedule.
Oh, schedule.
Schedule. So we're going to schedule on an interval, and this can automatically just do it every frame, or you can have it. You can perform multiple scheduled actions to occur. So you might have some particle exploding like every 5 seconds over here, multiple enemies spawning in. So for instance, in my game that I created, I had these little balls like coming and schedule them like every 5 seconds to pop up in the game. So you can have these random events per se.
Right.
So we're going to schedule, and what this is going to take in is an action, and we can see it's a float action here, which is going to be our run game logic method. So now every single frame of our game, and we can obviously optimize this. It doesn't have to be every frame per se, but it's going to run this game logic here. Boom. So let's do one other thing here. Is we know that if the ball is overlapped and we're moving down, that we are going to reflect it back up. So we want to increase the score. So I've gone ahead and put a little score equals 0 up top here. So let's just say score plus plus. And then of course we have our label that we created, and we'll set the text equal to format, and we can say score, and we'll just put the score in there. So that way we're increasing the score so we know what's going on. All right, so let's go ahead and run this again. So now our ball is going to drop automatically because we've scheduled this to run, and I'm going to be pretty quick to make sure that I can do this. Right? All right. There we go. And we can see our score increase there. It's bouncing off the walls automatically.
Wow.
Back and forth. All right. So we're going to run into one issue, of course. If I just like don't move. Let's just say I go here.
Which is what, you're going to die of boredom before you finish?
Yeah, boom. So now our ball's off the screen, right?
Yes.
So it's completely gone.
Well, good. You lost.
Lost. But we didn't tell our user that at all. So what we could come down here and say is we could say if our ball, where's it at? Our ball sprite dot position y is less than our visible world space dot max y. I think it's greater than. I think it's what I want to do. Let's see if that's the logic. What we can do is we can go ahead and reset our ball. So if we go ahead and grab our logic here and just like reset our ball sprite here.
That's pretty generous.
Yeah, we're just going to grab this here. Just going to put it back up, and we'll actually go ahead and say ball y, and we'll go ahead and multiply that because we want to. It's moving down, so we want to move it back up, and then we'll say score equals 0, and we'll say label dot text equals score 0. Now, I think that it should be dot min y. I think it should be less. We'll see if that works or not. Let's give it a go. All right. So at least we want to reset the game. At least we'll have something that's recurring. We could obviously add a lot more features to this game. Very simple to actually build something out in just a few minutes. There we go. So let's see if my logic here is going to fix. And obviously now you could adjust all the different gravities and things like that. There we go. Oh, now of course I've launched it up because I guess I modified it incorrect. Oh, it's just blank. There we go. Boom. So we have a few different issues in there as well. So for instance, our main issue is that we didn't reset our ball velocity here. So that's what's kind of occurring at this point. So we could go ahead and grab our velocities here and reset them as well. I'm just going to put them at that. I think I reset it to 0. That way it automatically does it based off the time. So reset all of our velocities. That's why it shot up, because it already had a velocity going down. Perfect. Okay. So the simplest of games that we could think of to demo here, right? And it's kind of setting it off. All right. So now how do we get this on Windows Phone, you might be asking?
Well, my first question is, where do I go and learn about all of this code you're writing? Is there good documentation? There typically is good documentation on the Xamarin site. I assume that you continue with that?
That's correct. So inside of the CocosSharp templates here, there's actually a complete walkthrough of doing everything. So we give you multiple things. Okay. We have the CocosSharp wiki, and there's also where's it at? All the samples. We have samples that'll walk you through as well. So our samples at CocosSharp samples, there's actually about 9 games in here that you can actually just download and automatically get started with, from Air Hockey, Angry Ninjas, Gone Bananas, a bunch of different type of games on there as well. And the one that I'll show up.
There's an API reference though.
Yeah, so we do have an API reference as well. So we have a full walkthrough. So this one's really good. This will walk you through adding everything through an entire game to build this game one at a time. It's really nice.
Oh, cool.
It's a little bit more than this episode. It'll take you maybe like an hour or 2 to go through. But at the end of it, you get this entire banana game with parallax and everything crazy as well, and all these monkeys. It's really great. And when you go to developer.xamarin.com, we're going to find some documentation in there. So if we just go ahead and tap on the cross-platform, where's it at? So when we tap on cross-platform up here, and you go down to game development, you'll see CocosSharp.
Okay.
So this will be full introduction, walkthrough, content pipeline, handling everything that you can think of, and API reference as well.
Cool.
Really big in there. Yeah.
All right.
So that's where you get going. And the whole CocosSharp GitHub repo will walk you through all of that. So if you wanted to take all this logic and now put it on another platform, all you have to do is add another project. So let's add a Windows Phone project, for instance. There's Windows Phone, and we'll call this Bouncy WinPhone. So this will handle all the Windows Phone specific intricacies there. So all we have to do now at this point, and we can see it added a new app delegate, and it added a new intro layer. Now we don't.
Now you could put those in a portable class library, couldn't you?
You could, absolutely. Yeah. So you could come in and add a new portable class library,
Right.
add CocosSharp, and you're good to go.
Okay.
You could also, though, do this. You could just say add new project, and let's just add a shared project.
Shared project.
Yeah,
okay.
why not, right?
You can do either one.
Yeah, so let's add like a bouncy.shared in there. So now what we could do is we could just move. We know that we want to share 100% the app delegate and the intro layer here. So we're just going to move those into our shared. We can now delete these out of the Android project, delete these out of the Windows Phone project, and then simply add those as a shared project here. So this is great because now all that logic, so imagine this is a very more complex game, right? Not just the little ball bouncing in here, for instance, but we can go ahead and add this shared project, add that there, and now we're basically almost good because the only thing we need to do here is add the content here. And Windows Phone handles some things automatically for you. PNGs work really great out of the box on iOS and Android, but not so much on Windows Phone. So there's this tool that you'll find in the documentation called the pipeline tool, which will take any of your resources, whether they be MP3, WAV files, PNG, JPEGs, and it'll convert them to a cross-platform file format automatically for you. So that's what I've done here, and this is what I could have added to Android originally, but here I'm just going to drag in these XNB files, they're called, into here. If I put this on Windows Phone, and let's make sure that everything is set to build. It looks good. Spin up the Windows Phone emulator here. Oh, all right, we got to do one other thing. Resolve that namespace. Of course, you want to clean it up. You probably don't want to call it Bouncy Android per se, but that's one other thing, because here's the phone application page, so it's just one line of code here in the Windows Phone project.
Okay.
To start it up. There we go.
So we had to add a reference to the Android project inside the phone project?
Yeah, so here's what happened there, is we created these app delegates, namespaces.
Got it,
yeah,
okay.
Yeah, namespaces.
Right.
But you could change those namespaces.
Yeah.
Oh, and we can see one big issue here is that we didn't change it to portrait. So let's go ahead into our game page and change that to portrait here. So again, it's just actually using a phone application page. So everything, if you're done Windows Phone development, here. So we have supported portrait and our orientation. So let's go ahead and try that one more time. There. Yeah, so ideally here, you'd probably start with a shared project, and these would just be named bouncy.shared in your namespace. So that's what happened there. And when you look at my final project that's on my GitHub, it's called Bouncy Game on my GitHub /James Montemagno, you'll see the game there as well. So ideally, our paddle is somewhere. Where did it go? Let's double check to make sure that our properties are set to content.
Oh, that would be helpful.
Every time. There we go. Let's try this one more time. So it didn't crash, which is interesting, which is good, I guess. Maybe it should have. But
I personally think it should crash.
Probably should crash. Tried to load
like
the
that.
resources, but didn't. So that's good. So now here we go.
There
So
we
now
go.
it's the full thing.
Platform game.
Right?
Sweet.
And I didn't change any lines of code besides putting it into portrait automatically for me. And we can see that it's going to go ahead and move automatically. And all the game logic there is shared across platform.
Cool.
Yeah.
Yeah.
So not bad. Yeah, and I want to show you the sample that you can walk through as well. So that's the Bouncy game. Now you can do it on iOS. You could do it on all the other ones. You're going to actually walk through when you go through, and there's this project called Gone Bananas, which is really cool. It shows off almost all the different features in CocosSharp from particle systems to parallax to just about everything. And it's really fun. And it shows you how to do scene transitions and everything like that. So it's a little bit more complex, but we can see it has a Windows Phone, Android, and iOS, and a big shared project.
Right.
So there's multiple physics sprites, overlays in here as well. And it uses sprite sheets as well, which we talked about, which is really cool. So let's go ahead and take a look at this here. We're going to tap to go bananas. We got a little banana guy in here, and the whole idea is to catch all the bananas before you actually hit a ball. It's actually really difficult. We made it extremely difficult on here, but you can see like the clouds are moving and different particle effects are going on as well. See if I can get any bananas. And there's multiple game modes as well that you can put on this one, which is kind of cool. It kind of shows off different features. 5, that's not bad. That's my high score, actually.
Okay,
Just did that
excellent.
right now. So, and this is, of course, cross-platform. And this is showing a little bit more on there as well on how to load backgrounds, more than just a little bouncy ball. And then we have a lot more complex games as well, just so you can get up and running. But I just wanted to show you the basics of, let's add some cross-platform sprites on there, add some actions, and get going.
Cool. Excellent.
Cool. Yeah. That's about it. Of course, you want to, go to github.com/mono/CocosSharp. And the PowerPoint presentation that I started with is going to be a little bit more involved. We'll have links in the show notes as well with how to get started on everything, with all the references, of course. Yeah.
That's awesome.
Yeah.
That's a great way to get started with gaming.
Yeah, it's you're not gonna. You could potentially build out a really complex game, but if you're just looking for the first time to get into gaming,
just something fun for the kids or for yourself,
Exactly, and since it's all node based, it's kind of really easy to understand even just in the code, which is what I really like about CocosSharp. Yeah.
Yep, and then it follows the same paradigm. It's shared projects or PCLs, and all in one place, and then. Easy way to do cross-platform.
Yeah, absolutely.
That's awesome.
Yeah.
All right. That was fun.
Yeah.
All right. We will see you next time on Visual Studio Toolbox.